Okay, student, here we shall see another topic, that is Bayet and Sabat law. So if you remember in the previous lecture video, it was Oersted who first discovered about the magnetic field produced by a conductor carrying current. So now this Bayet and Sabat, they worked together to find out the magnetic field due to any types of conductor. So they consider a conductor like of irregular shape in this case, and this conductor, let's say it is XY. Okay. Now, in order to find the magnetic field at any point P, let's say, Bayet and Savart, they divide this total length of the wire into small current elemental length, which means they divide like this. They divide, the whole conductor. If this is a conductor, then divide this whole conductor into small current element dl in this case. Okay. Now, if they want to calculate the magnetic field at a point P, then they have to first know about what is the magnetic field at this point P due to this current element dl. Okay. Now, this point P, it is right having a position vectors r with respect to the elemental length dl. And according to Bayet and Savart law, they says that this small magnetic field dB at a point P due to this small elemental length dl, it is found to be directly proportional to I dl sine theta and inversely proportional to the square of the distance between them, where theta in this case, it is the angle between this r and dl. Okay. Okay. Now, usually in physics, when we remove this proportionality signs, we write some constant, let's say k, and that idl sine theta upon r square. Now, what is k? K is a constant of proportionality, and its value depends on the medium between the point P and the length dl. So what is the medium between them? Okay, so that medium will actually determine will affect the magnetic field dB. Okay, so if this medium between the point P and the current element dl here, let's say it is a vacuum or a free space, and the unit that we are choosing in this case, let's say in SI unit. So this k here is equals to mu naught upon 4 pi. So this value of k, it is actually uh, equals to mu naught upon 4 pi when the medium is a free space and the unit is in SI unit. Alright, so this is the value of k. And this mu naught here, it is known as permeability. Okay, so this constant mu naught, it is just like epsilon naught. Epsilon naught. What is epsilon naught? It is permittivity of free space. Similarly, mu naught is permeability of free space. Okay, so please remember this point here, that when you are talking about the charge at rest, that means, yes, like in electrostatic, then the constant here we use is epsilon naught. But when there is a current passing through the wire, which means a charge is moving here, so the constant we use, it is known as permeability of the free space, that is mu naught. Okay. So substituting this constant value k is equals to mu naught upon 4 pi in this equation, let's say this is equation 1, then we will get dB is equals to mu naught upon 4 pi I dl sine theta upon r square. So this equation, let me name this as equation number 2. So this equation 2, it gives you the magnitude of the magnetic field at a point P due to this current element dl. So Bayet and Savart, right, they found that dB is equals to this much, and if they know the value of the magnetic field at this point P due to this current element, then they can find out the magnetic field at this point P due to the entire length of the wire. So for that, they will just integrate this equation number 2 and they will get the total magnetic field at a point P. Okay. So please note down here that this equation 2, right, it is just the magnitude of the magnetic field at a point P due to the current element. Okay. Now this magnetic field, once again, it is a vector quantity. When I say a vector quantity, it means it has a direction. So if it has a direction, then I will rewrite this equation 2 in terms of vector form like this. dB here is equals to mu naught upon 4 pi I dl sine theta. I will multiply and divide by r. Okay, if you multiply by r and divide by r, so this r square will become r cube. Okay, or your dB in this case is equals to mu naught upon 4 pi I. Now I will rearrange the term dl r sine theta upon r cube, or I can say this dB is equals to mu naught upon 4 pi. Now what is this dlr sine theta? This dlr sine theta, it is equals to dl cross r upon r cube. So please remember, this is the vector form of the magnetic field at a point P due to a small current element. So if it is a vector, then I have to put an arrow on top of this dB. Alright, okay. So now let us find out what is the directions of this magnetic field dB. The directions of this magnetic field dB, it should be perpendicular to the plane containing dl and r. Okay, which means if this is dl acting in this direction and this is r acting along this direction. Now these two vectors, let's say they are lying on this plane. Okay, so at this point P, the directions of the magnetic field, it should be perpendicular to this point P and it is directed inward, right, perpendicular to the plane of the boat. So this is all about Bayet and Savart law, and we shall use especially this equation 2 when we solve or when we do the applications of this law for different types of conductors, like for a straight conductor or a circular loop which carrying current, and and so on and so forth. We have so many applications of this law, so for that we shall see in the next lecture videos.